Okay, so continuing from those examples, notice again we've got degree of 2 on this factor, degree of 1 on this factor, so that means that the whole thing is the degree 3, which means that's going to be a cubic. The ends go in opposite directions. We've got 1, 2 turning points, 1, 2 zeros in this case, and notice that the quadratic root is at x equals -5 and the linear root is at x equals +4 because of the degree of 1 here. Positive lead coefficient, so the graph is increasing from left to right. For this next one, the quadratic root is at x equals +5. The linear root is at x equals -2. Negative lead coefficient, so the graph is generally decreasing from left to right. 1, 2 turning points, in this case 1, 2 zeros. The last one here, negative lead coefficient, so the graph is generally decreasing. Quadratic root is at x equals 0 and the linear root is at x equals +3. 2 turning points and 2 roots, or 2 zeros. One extra thing I forgot to mention is look at, so we looked at the turning points, 2 turning points for degree 3, 2 turning points for degree 3, 3 turning points for degree 4, again 3 turning points for degree 4, but look at the zeros. 1, 2, 3 zeros for degree 3, 1, 2, 3 zeros for degree 3, 1, 2, 3, 4 zeros for degree 4, and the same thing for this one. Notice from our quadratics, 1, 2 zeros for degree 2 and 1 turning point. 2 zeros for degree 2, 1 turning point. Moving right along. Okay, now we'll continue with other types of quartics here. Again, take a look at the same sort of characteristics as always. Lead coefficient is positive. Here's degree 2, here's another degree 2, so that would be a degree 4 when you multiply them all out. And then we've got a quadratic root here at x equals -1, a quadratic root here at x equals 2, corresponding with the power of 2 here for the factor of x minus 2, and this quadratic root at x equals -1 corresponding to that power of 2 on that factor of x plus 1. 1, 2, 3 turning points, degree is 4, lead coefficient is positive, meaning that the graph is opening up, and both ends go in the same direction. For part B, again, degree 2 and degree 2, you multiply them together, you get degree 4. Lead coefficient is negative, so that means it's opening down. The two ends go in the same direction because it's degree 4. We've got one quadratic root at x equals -1, corresponding to this factor with the power 2, and one quadratic root at x equals +2, corresponding to this factor of x minus 2 squared. 1, 2, 3 turning points, and degree 4. Now it also has, because of this double root and this double root, there's actually 4 roots there, but just 2 distinct roots. So degree 4, 4 roots, even though there's only 2 distinct roots that you can see. Part C, quadratic root at 0, quadratic root at x equals 2, negative lead coefficient means it's opening down, degree 2 on both of those factors gives us degree 4, 2 roots there, 2 roots there, means there's 4 roots, but only 2 zeros where they cross the x-axis, 1, 2, 3 turning points for the degree 4. And the last example here for quartics, a quadratic root at x equals 0, a quadratic root at x equals -2, It's opening up because the lead coefficient is positive. 2 degree 2's, when you multiply them together, you're going to get degree 4. 2 double roots, which means there's 4 roots for the degree 4, even though there's only 2 distinct zeros, and there's 1, 2, 3 turning points. Okay, sketch these graphs, please. Okay, so we've got degree 4, so it's a W shape opening up because its lead coefficient is positive. Zeros at 4, x equals 4 and x equals 6. They're quadratic roots because they're both of power 2. So they're both double roots, which gives us actually 4 roots, 2 distinct zeros with degree 4 and 1, 2, 3 turning points. Negative lead coefficient, so it's opening down. It's an M-shaped curve. Degree 4. Zeros at x equals 4 and x equals 6. They're both quadratic roots. So 2 double roots, which gives us 4 roots and 2 distinct zeros, and 3 turning points for a degree 4 function. And again now, quadratic root at 0 and at x equals 4. Opening up because the lead coefficient. W shape because it's degree 4. 2 double roots at 0, 2 double roots at 4. So there's 4 roots, but only 2 distinct zeros at x equals 0 and x equals 4. Okay, so moving along to something a little bit more complicated here. We have, what degree is this? We have a degree of 4. Positive lead coefficient. We have a linear root at x equals negative 1 and a cubic root at x equals 2. Notice how there's a little wow there in the curve. That's kind of like the vertex of a cubic. That's where it should be crossing the x-axis. Okay, so when you draw these, make sure it's very accurate. Positive lead coefficient means that it's opening up. It is kind of like a W shape, a little bit smoother here around the cubic root. And we've only got 1 turning point in this case, not the usual 3. And we've only got 2 zeros. This is a triple root, the cubic root, the triple root, and here's 1 linear root. So we actually have 2 distinct zeros, but 4 roots, 3 here and 1 here, given by the powers. For part B, lead coefficient is positive, it's opening up. 3 and 1 is the degree of 4. Okay, so we've got here a cubic root at x equals negative 1 and a linear root at x equals 2. 3 roots here, 1 triple root, so 3 roots and a linear root. So altogether there's 4 roots but 2 distinct zeros. Ends go in the same direction. Only 1 turning point and 4 roots. Again, degree 4. 1 turning point. Lead coefficient is negative, so it's opening down. It is kind of, M-shaped, sort of. Here's a linear root at x equals negative 2. Here's a cubic root at x equals 1. 1 turning point, 1 single and 1 triple root, so there's 4 roots but 2 distinct zeros. And the ends go in the same direction because it's an even degree. Lead coefficient is negative, it's opening down. It's M-shaped. There's 3 there and 1 there, so there's a degree of 4. We've got a triple root at x equals 0 and a linear root, a cubic root at x equals 0 and the linear root at x equals 2, corresponding to that factor. 3 roots here, three triple roots, or a triple root, 3 roots there, and a single root. So there's 4 roots, but 2 distinct zeros. Ends go in the same direction because of degree 4, and in this case only 1 turning point. Okay, sketch these curves please, and come on back in a second.